Hello everyone, welcome to our daily physics problem, day 4. So today we have a ball slides down from the point O to point A along the incline OA starting from rest. What is the angle phi required in order to make the time interval the shortest? So this is a kinematic problem that requires to solve for the fastest incline. So let's pause the video, try on yourself, and then after you try it, come back to the video and I will show you how I did it. Okay, welcome back. So first let's figure out some geometry. First we can know these two lines are parallel to each other. This angle will be theta and this is right angle, so this angle will be 90 degree minus theta. Same reason this is 90 degree minus phi. And the total angle add together will be 90 degree minus phi plus theta. Then let's define the point B and C, D as the distance from O to C, and L as distance from O to A. And L is the one we want to solve. So according to the law of sine, D over sine A will be equal to L over sine C. So D over sine A, what is A? A is equal to 90 minus phi plus theta, and C equals 90 minus theta. Then D over sine times 90 minus parentheses phi minus theta. Then we can simplify it into the right side. We just simplify the cosine theta. The left side the cosine phi minus theta. Then we know d times cosine theta will be equal to L times cosine phi minus theta. Then L will be equal to d times cosine theta divided by cosine of phi minus theta. Then we solve for L in terms of geometry. But we also know that L is equal to a half times acceleration times t squared. That's our kinematic formula. And then we also know that acceleration equal to g times cosine phi, and then we times t squared divided by 2. So let's now solve for t, because we need to find the fastest time we need. So we can move t to the left hand side. T is equal to 2 times L over G times cosine phi. Then all of them over square root. Then let's plug in L as we solved on the right hand side. 2d times cosine theta divided by cosine of phi minus theta, plug it in. Then we solve for t as the minimum. So in here, actually we don't have to solve entire t to minimum, because we only need to care about the variable. It's our angle phi. So we need to make cosine of phi minus theta times cosine of theta the maximum, so that we can know t have to be minimum. So let's take the derivative of it and set it to 0. Then we have negative sine phi times cosine phi minus theta plus cosine phi times the negative of sine phi minus theta, and then that will be equal to 0. So let's move the right equation to the right hand side. We have minus sine phi times cosine phi minus theta equal to cosine phi times sine of phi minus theta. Then we divide both sides by cosine theta, then divide by both sides by cosine phi minus theta. We have negative tangent phi equal to tangent phi minus theta. Then we have phi equal to cos theta divided by 2. Then let's check the answer, why this is true. As you can see, tangent is an odd function, so negative tangent of a number will be equal to tangent of negative that number. So now we got the final answer here.